What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to deal with optimization questions. A cylinder can is to have a volume of 1 liter. Find the height to radius of the can that will minimize the surface area, and what is the ratio of height to diameter. We know the can is cylinder and the volume is gonna be pi r squared times h, and the surface area is gonna be pi r squared, so 2 pi r squared plus surrounding, which is gonna be 2 pi r times h. V, the volume here it says is 1 liter, so I'm gonna say pi r squared times h is gonna be 1000 cubic centimeter, which means that h is 1000 divided by pi r squared. So here we need to find the derivative of surface area with respect to r, because we need to minimize the surface area. So it's going to be 4 pi r plus, that's basically 2 pi r squared plus 2 pi r. Instead of h I can write 1000 over pi r squared, which will be 2 pi r squared plus pi and pi cancel out, r with one of the r cancel out, 2000 over r. So it's going to be 4 pi r, that's the derivative of s with respect to r, minus 2000 over r squared equals to 0. Then we can say 4 pi r equals to 2000 r squared. Then we can say 4 pi r cubed equals to 2000. So r cubed is going to be 2000 divided by 4 pi. So r will be cube root of 2000 over 4 pi, which will be around 5.4 centimeter. So when r is 5.4 centimeter, we can find h. H will be 1000 over 3.14 times 5.4 squared. It's going to be 10.9 centimeter. That's the height of the can. And in part B it says what is the ratio of height to diameter. Height to diameter is going to be h over 2r, which is going to be 10.9 over 10.8, which is going to be almost equals to 1. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.